So picture this. What if the next CEO of a major corporation wasn't a person at all, but an AI? And not just an AI that's good at spotting patterns, but one that actually makes strategic decisions based on a concrete ethical rulebook. Well, that's exactly what we're going to get into today, a fascinating blueprint for how to build one using the power of game theory.
Now, I know what you're thinking. That sounds like straight-up sci-fi, right? But this question is getting more practical by the day. We've got AI that can chew through massive data sets in seconds. But can we actually build one that can lead, make the tough calls, and, be held accountable? That's the massive challenge we're going to unpack here.
Okay, so what's the real problem? See, modern AI is built on machine learning, and it's amazing at being a sensor. It's the eyes and ears that can tell us what it sees in all that data. But here's the catch. Machine learning isn't a strategy. It can't decide what to do with that knowledge. For that, an AI needs a playbook.
All right, so here's our game plan for today. First, we're going to talk about why AI needs a strategy in the first place. Then, we'll get into how we could build a rulebook for its decisions. We'll ask a crucial question. What game is this AI even playing? From there, we'll define its ultimate goal, and finally, we'll look ahead to the future of this kind of AI governance.
Right, so first up, why does an AI even need a strategy? Well, it's pretty simple, really. Just throwing more data at it isn't going to cut it. To actually lead, it needs a consistent, reliable framework for making decisions. It needs a real strategy. And look, when we say strategy, we're not talking about some vague mission statement you'd see on a poster. We mean something super specific. A complete description of how the system will behave under all possible circumstances. Every single eventuality has to be covered. Okay, so how on earth do you build a playbook that covers everything? Well, the idea here is to use game theory. And don't worry, you don't need a PhD for this. Just think of it as a practical tool for programming decisions, almost like creating a logical brain for the AI. This whole process is broken down into 5 key steps. First up, you use something called computational law to basically translate human rules and ethics into code the AI gets. Second, you train it on a ton of synthetic data, all sorts of tricky ethical scenarios, so it can practice. Third, machine learning kicks in to analyze whatever's happening in real time. Fourth, game theory does its thing to figure out the single best move. And finally, explainable AI tells us humans why it made the choice it did.
For any of this to work, the AI first has to figure out a really basic question. What game am I even playing right now? Is it a negotiation with a supplier? Is it a supply chain crisis? Or is it a simple safety concern from an employee? Getting the game, the rules, and the players right is absolutely the most critical first step. And the players in these games? Well, it's not just people. The AI could be going up against other AIs, teams of humans and AIs working together, or even something the researchers call nature, which is basically a player that acts randomly, representing anything from a hurricane to a sudden market crash.
Okay, but this is where it gets really cool. When you build ethics and the law into the AI's core programming from the very beginning, it completely changes the game. See, when being ethical is mandatory, some of those classic thorny dilemmas from game theory, they just kind of melt away.
Think about the classic prisoner's dilemma, right? Normally, you're trying to figure out if you should cooperate or betray the other person. But for an AI that's hardwired to be ethical, there's no dilemma. It's not allowed to betray you. Its programming says it has to cooperate, and if it accidentally causes harm, it has to fix it right away. Betrayal isn't even on the table. The problem just vanishes.
And that brings us to what is, honestly, the most powerful idea in this whole paper. The concept that every single decision, every strategy, and every little subgame the AI plays is all governed by one single, highest priority game that it is always playing, no matter what.
It's called the base game, and its one and only goal is to preserve and protect human life and well-being. Period. Think of it like a rule in chess. You can never make a move that puts your own king in check. It's a fundamental rule that overrides everything else. This is that rule for the AI. Okay, let's make this real with an example straight from the research. Imagine an AI has to buy some safety gear for an employee. It can choose between high, medium, or low-grade equipment. The tricky part is nature. The weather could be totally fine, a little dangerous, or a full-on disaster.
Okay, so here's what the AI is looking at. A 1 means the employee is safe. A -1 means they're in danger. Now just look at the chart. The high-grade gear, it keeps them safe no matter what. But the medium and low-grade stuff, well, that starts to fail when things get nasty.
So how does the AI choose? It uses a model called Wald's criterion. And honestly, you can just think of it as being programmed to be a safety pessimist. It looks at every single option and asks one simple question. What's the absolute worst thing that could happen? For the cheaper gear, the worst case is failure, a -1. For the best gear, the worst case is still success, a +1. The AI is programmed to pick the best of the worst outcomes.
So what does this all mean? It means that for an AI that's playing the base game, there's only one logical choice. It has to buy the expensive, high-grade equipment. Why? Because it's the only option that guarantees safety in the worst-case scenario. When human lives are on the line, this AI is built to take zero risk.
Okay, so let's zoom back out for a second. What would these AI leaders, actually look like? Are we talking about some robot sitting in the corner office? Well, the paper suggests it's going to be a bit more complex than that.
Well, we can imagine a few different models. You've got these huge digital command centers, which are basically giant data-crunching factories. Then you have the more personalized systems. Think virtual agents or even humanoid robots that we can interact with. But the most likely path forward? It's probably a hybrid of the two, combining that raw processing power with a user-friendly interface.
And there's a really simple reason for that. A standalone robot, walking around an office, it just doesn't have the raw computing power for this kind of work. Making these massive ethical calculations on a global scale, maybe using something like the UN's Sustainable Development Goals, that takes the horsepower of a digital factory. The robot you see would just be the friendly face for a much, much bigger brain.
So this whole framework, it gives us a really powerful vision for a rational, ethical AI leader. But it leaves us with one last and honestly huge question. If we're gonna build an AI to optimize for human well-being, who gets to define what well-being actually means? And that, right there, might just be the hardest game of all.